Hi everyone, here's the first SoftFIRE webinar, and I'm gonna present to you the SoftFIRE platform, and I'm going to show you a video with a full tutorial of an experiment. My name is Daniele Carmignani and I work in security reply, and I'm involved in the SoftFIRE project. So first, a brief introduction on the SoftFIRE project. SoftFIRE is an European-founded project of the duration of 27 months, so till spring of 2018. And in particular, it's composed by a consortium of partners, and these are listed here. So we have the AT Digital, the Deutsche Telekom, Ericsson, the Fraunhofer Focus, Reply, the Technical University of Berlin, the University of Surrey, and Assembly Data System. So the main goal of this project is to obtain the integration of experimental facilities, testbeds, and laboratories. So about SoftFIRE, what we want SoftFIRE to do is to build a federated experimental platform aimed at construction of services and functionalities on top of the concept of NFV and SDN technologies. I assume that you know the concept of NFV, network function virtualization, and software-defined networking. The other main aspect of the SoftFIRE platform is to be a federation of already existing testbed, and they are owned by the different partners of the SoftFIRE consortium. Every partner offers to the consortium both technical skills and also resources in terms of computational resources or whatever. SoftFIRE has got three main key elements that are the interoperability, the programmability, and security. Interoperability because it wants to interoperate different technologies and different data centers between themselves. Programmability because it wants to offer to experimenters the possibility to program its platform, and security because it wants to offer security functionality, and because it thinks that security cannot be left behind these other two main topics. And so the main ambition of SoftFIRE is to improve and support the SDN and NFV environment, creating a federated platform able to offer also the possibility to study the future 5G technologies, and wants to be a reference implementation for all these experimental platform and technologies. So now that I've said something to you about SoftFIRE, you may want to be involved in SoftFIRE project. SoftFIRE strictly wants to interact with third parties and offers a series of different events. Events offered by SoftFIRE project are of different type. We have the main, events that are the waves. The wave consists in a period of open call when interested third parties can make their own proposal based on the SoftFIRE infrastructure. These proposals are sent to the SoftFIRE consortium, which selects the best ones, and then the selected proposal have 3 months of time to actually perform the experiments on the SoftFIRE testbeds. At the end, every experiment has to reach a set of KPI based on the experiment in order to demonstrate that the experiment successfully has been executed. Another type of event are the hackathons. Hackathons are events spread among 1 or 2 days, and interested participants have to register and they challenge each other. So at the end of the hackathon there will be prizes, and only a part of the participants will win these prizes. Then we have the final challenge, that is a, let me say, combination of these other events, and will be a major final event with great prizes that will take place in the next year. And the last type of the event are the open days. Open days are thought to let the interested people to get familiar with the SoftFIRE platform, so they can ask for free access to the platform for 1 or 2 days, and they can explore the SoftFIRE platform if they want, for example, to then make a proposal during one wave or participate to the hackathon. So these are the dates and the link where you can register if you are interested in. So we have the open days that are, the first open day are in these days, and this webinar is the welcome to you to these open days. Then we'll repeat this event at beginning and at the end of the October. Then we'll have in November the second hackathon. It will be in Berlin, and you can apply till the 27th of October on the link that you see in this slide. Then we have the third wave of experiments. As I said, the actual wave is a period of 3 months, and in this case it will cover November, December and January. So you can apply till the 4th of October, making your own proposal based on the SoftFIRE platform. And as I said, the final event, the final challenge will take place in February and March 2018, but details will be better defined in the next period. So in this slide you can find all the useful links. You have the SoftFIRE website, where you can find all the information about and documents about all these events, emails, how to be involved, forms, etc. Then you have the documentation website, where you can find every technical information on the platform, how to run your experiment, how to build your experiment. And I kindly suggest, if you are interested in one of our events, to have a deep reading of this, let me say, great website. Then to be in touch with the SoftFIRE team, to ask questions, to have a deep contact with the SoftFIRE team. We have a Slack channel, and you can obtain a registration link going on the website that is in this slide. All the SoftFIRE team is on Slack, so you can contact us and you can ask questions or whatever, and you can be in contact with other people interested in SoftFIRE project. So let's start the main part of this tutorial. I introduced you how to run your experiment inside the SoftFIRE platform, and I show you a video of a complete experiment. So the preliminary operation that you have to do is to register. So the SoftFIRE platform is not an open platform, so only authorized people gain access to it. So you need to register to one of the events that I previously shown you, and then when you be selected, you will be authorized to gain access to the SoftFIRE platform, and you will receive the the credentials, the instruction, and whatever. Then you will need to connect to the SoftFIRE OpenVPN, because as I said, SoftFIRE platform is not an open platform, so everything is inside a private VPN, so you need to connect to it in order to use our facilities. So this is a high-level overview of the SoftFIRE platform. We have at the bottom part, the lower part, the test beds that are offered by some of the partners of the consortium, and on top of these test beds where the actual virtual resources are deployed, you have the SoftFIRE middleware. The SoftFIRE middleware, I'll show you deeply in the next slides, is a software layer that offers to the experimenters a programmable interface in order to exploit the functionalities of SoftFIRE infrastructure. And so in this slide you can see in deeper detail the software architecture of the SoftFIRE platform. This is the current version of the SoftFIRE platform. We plan to improve the number of resources that are made available, but more or less the software architecture will be the same. We have in the lower part of the software architecture, we have the OpenStacks. The OpenStacks controls the test beds controls the physical resources of each test beds and deploys over it the actual virtual resources. On top of the OpenStack, we have the NFV orchestrator that for this project is OpenButton. It's deployed by the University of Berlin, one of our partner, and it's an NFV orchestrator that follows the specification of the ETSI. So on top of this, let me say, standard software architecture, you have what we call the SoftFIRE middleware, that's shown in red, and this is the interface that is exposed directly to the experimenter. The SoftFIRE middleware composed by a top component that is the experiment manager. The experiment manager manage the life duration of the experiment, so it's directly exposed to the experimenter, which can use it through a dashboard or through its API with a command line interface, and the experimenter can deploy machines, can define its own experiment, can actually deploy it, can delete it, and whatever, can see information that the answer provided by the experiment manager contains all the information about every resource that the experimenter decided to deploy inside the SoftFIRE testbed. And so the experiment manager is the let me say front end of the SoftFIRE middleware. Instead, in the back end, you can see from this picture a number of 5 managers that we'll see in a little more detail in the next slides, and each of these ones manage a certain type of resources, interacting with the lower architecture of the SoftFIRE. So, for example, you can have the SDN manager interact with the SDN controllers that are in some of the test beds of the SoftFIRE platforms and offer a interface to the experimenters. But we'll talk about them in the next slides. So we start from the front end, the experiment manager. What you can see, this is the dashboard. We'll see in the video later. And in this dashboard, you can have information about your current experiment, and you have listed all the resources that are made available by the SoftFIRE platform. And on the left side of this dashboard, you can see the reserve resources button that you can use to actually instantiate your experiment. So how to define your experiment? What's used to define the experiment is the Tosca language. Tosca stands for Topology and Orchestration Specification for Cloud Applications, and is a standard language for this kind of architectures. And what as the experimenter to upload is a CSAR folder, so a cloud service archive, and this is a zip folder composed by different sub layers. We have the definitions folder, where on the inside there is the experiment definition that we'll see deeper later. Then we have the files folder that contains some useful packages for the definition of new NFV resources, of custom NFV resources. And then we have a Tosca metadata folder. Inside this Tosca metadata you have a file metadata.yaml, and this contains just the experiment name and, more important, the start and end date of the experiment. So the experiment manager also provides a certain duration for the experiments. So when the end date is fired, then the experiment is deleted automatically by the experiment manager. And the last file is Tosca meta, and this contains just some information about versioning and, more important, the location, the path to the experiment definition file. This is the experiment definition file. It records the node type file that you can find on this link. So in this file you can find the definition of the Tosca definition of every one of the resources that are offered by the SoftFIRE infrastructure, and you can, so each resource has its own syntax, and inside this file and inside the documentation file you can find all the properties that you can define inside this experiment.yaml file. In this case, for example, you can see 3 resources. We define a Zabbix server, an SDN, that we require access to the SDN controller inside Ericsson, and we deploy an iPerf network function inside the Ericsson testbeds. So let's start focusing on the specific resources that you can find in the SoftFIRE platform. The first one, and probably the most important one, are the NFV resources, network function virtualization resources. And these resources represents the network services in the ETC NFV terminology. As I said, the ETC specification about NFV are the reference that are followed by this project. And as I said, the open button orchestrator is used to actually deploy the network services in the testbeds that you select, and open button is responsible to manage the life cycle of these resources. Here you can see the definition of the NFV resource and the description of the properties that you can use. You have every resource is paired with a resource ID that identifies the type of the resource. In this case, you have to select the testbeds. The testbeds, you define a map between the specific virtual deployment unit and the testbed where you want to deploy it. Then you have to specify the NSD network service descriptor name, and you have to define the file name in case you want to upload your own NF network function virtualization resources. In case you want just to recall one of the pre-configured NFV resources that the SoftFIRE project made available to you, you don't need to define the names. And then you can upload, you can copy and paste in this file your public key. This public key will be injected on the virtual machines that are deployed by the open button, and then you will be able to connect through SSH to these machines by means of your own private key coupled with the public one that you paste in this file. So at the moment, the resources that are directly provided to you by the SoftFIRE project are the iPerf. And iPerf is a tool composed by a client and a server that make measurements about the bandwidth between these two components. And the other one is a complete OpenIMS core and is composed by all of these different components of the IMS core. Then you can, as I said, define your custom resources, and this is the example of a definition of a custom resource. In particular, apart from the properties that we have seen also in the previous slide, you need to pay particular attention to the definition of the packages where you actually define your own resource. And since the orchestrator used is open button, we suggest you to refer to official open button documentation to create the Caesar folder archive where you can put all the descriptors that are used by open button to deploy your NFV with your virtual network function. So this is a sequence diagram of the flow of operation when you want to create your own network services, and you can see that the experimenter interacts directly with the SoftFIRE middleware, which interfaces to the open button that controls the virtualization infrastructure manager that, as I said, it's OpenStack in this project. The second resource that we will cover is the physical resource. The SoftFIRE project wants to offer the possibility to third parties also to interact with physical components. In this case, physical components represents mobile phone that are placed in focus in this case, and what these resources do is simply to define that just that the experimenter is interested in using this kind of resources, but for the moment there is no remote access to these physical resources, so the experimenter are supposed to go to Berlin, to the University of Berlin, to actually use one of the physical resources that are directly connected with the core network that is physically is in focus. And for example, during the current during the current wave of experiments, some of the experimenters have asked to use these resources and are actually planning the travel to Berlin in order to use it. In a future version of the SoftFIRE platform, probably will introduce the possibility to remotely control these resources. The third type of resources that I introduced to you are the SDN resources. As I said, SDN stands for software-defined networking, and what the SoftFIRE platform do is to offer the interfaces to some of SDN controllers. Some testbeds inside the SoftFIRE architecture, as an SDN controller, and they have selected the SDN controller on their own. The proprietary of the testbed decided on his own the SDN controller to be used, and we have two type of SDN controller. We have Open Daylight that is used in assembly data system and Ericsson testbeds, and we have an Open SDN core that is our controller that is available inside the Focus testbed. On top of these controllers, we have an higher layer that abstracts these controller interfaces and offers in particular multi-tenancy to the experimenters, in order that every experimenter is able just to access and modify the flow tables that refers to his own project, his own experiment, and not the other ones. So let me say what we have defined on top of the actual SDN controllers is what we call the SDN proxy, that just acts as a proxy which forwards the requests, filtering them in case they are not and referred to the right experiment, and permits to the experimenters only to access to his own resources. This is an example. We have the Open Daylight proxy that is built on top of the Open Daylight controller, and so it, as I said, offer network isolation between the experiments. So skip these slides. We have an example of the answer that you get from the Open Daylight, from the SDN manager requesting an Open Daylight resource, SDN resource, but you'll see it later. And this is an example of the request. In this case, you can see a put request to push a new flow inside the OpenFlow node of the testbed, but I skipped this, and as you can see, in particular you can see an SP.A token field which actually give access to these interfaces to the experimenter, and actually is used to filter the request based on this value and the value of the table, the number of the table that are assigned to each experimenter. This is the example of the body of the request with the details of the flow that we want to push inside the OpenFlow table, and that the link that is in this slide, you can see all the details about this tutorial with the definition of some virtual machine and the interaction to the SDN controller in order to modify the flow, the forwarding of the traffic between these two virtual machines. The next type of resources that I want to introduce you is the security resource. Security resources are provided by the security manager, and what are these security resources? They are the common security agent that the experimenters can include in their experiments. They are provided by in form of dedicated virtual machines, standalone virtual machines, or the experimenters can decide to download the scripts and to modify them and to include inside their own virtual network function. So these are virtual resources. So the security manager, in case the experimenter wants a standalone virtual machine, the security manager interfaces through the open button to deploy the virtual machine and inject some configuration inside it, so that the experimenter is able to discover these resources up and running with his own configuration. To date, we have one security resource, that is the firewall resource, that is based on an Ubuntu machine with an uncomplicated firewall, and it also offers a REST interface to modify dynamically the rules of this firewall. Here you can see the definition of the properties of the security resource. Since these are virtual resources, as I said, you need to select the testbed where to deploy the machine. You have to define if you want to download the scripts or you want to deploy the virtual machine, and you can define some properties like some rules about allowed IPs or denied IPs that are pushed in the firewall, and you can define if you want your virtual machine to automatically send log messages to a remote log collector that is made available to you. This is an example of the answer that you get once your firewall machine is deployed, and you have an example of request, and these are the examples that you'll see later in the demo video. And this is the example, the image showing the dashboard that I explained, that I introduced to you before, where you can find log messages and some statistics about logs produced by your firewall. The next and last but not least resource that I want to introduce to you is the monitoring resource. The monitoring resource is provided by the monitoring manager component, and it installs a dedicated virtual machine pre-configured with Zabbix server. So the experimenter can decide to include inside his own environment a Zabbix virtual machine that can configure, to use, and to retrieve information about his own virtual machines about network. So here you can see the definition of this resource, and what you have to select is the testbed where to deploy this Zabbix server. And if you don't know Zabbix is a monitor system that is able to collect and store information from several types of devices, and it can collect information via agents, the Zabbix agents, via SSH, Telnet, log files. So once you deployed your Zabbix server, then you can configure your own virtual machines, your own virtual network functions to automatically send information to this Zabbix server. And you can find more information on how to configure it on the SoftFIRE documentation. And as I said, the Zabbix server that is deployed is completely dedicated to your experiment, so you have full access to this server and you can modify the monitoring rules and personalize whatever you want. This is an example of the Zabbix dashboard with some statistics. And so now once I have explained to you the resources offered by the SoftFIRE platform, I want to show a video and we'll comment it to showing the actual demo with a full example of all these, of the interaction with all these resources that I introduced to you.